Hello everyone, Ismail is here. Today we're going to start the lesson 18.2. You know, lesson 18.2 and 18.1 is likely lesson. I like them because they are very easy. They are using ratio, sine, cosine, and tangent. In 18.1, okay, we start learning the tangent. Okay, if you remember, we start learning in tangent. Here in 18.2, we are going to start sine and cosine ratio. Okay, try to solve these two questions. These two questions related to the tangent question. Okay, and if you want to find the lesson, you can find it on my website alfara-math.com. Okay, now let's start with the sine and cosine ratio. Here we have an essential question. It's asking, how can we use the sine and cosine ratio and their inverses involving calculation with the right angle? Okay, I will tell you something here. It's top secret between me and you. Okay, the same thing happened with the tangent. It's also working for the sine and cosine. Means when I'm talking about what type of triangle that we are going to use, we are only going to use the right angle triangle. So if my triangle is acute, or is it obtuse, or it's a scalene triangle, or whatever, so all of these sine and cosine not working with them. So you can use only the sine and cosine for the right angle. Okay, don't forget. So the same thing here, tan, sine, and cosine. We have a topic that combine all of these three, tan, sine, and cosine, with under one topic. So what's the topic? We call them here trigonometric ratio. So when someone asks you what are the trigonometric ratio means, trigonometric ratio means it's represented by the sine and cosine and the tangent. So all of these called a trigonometric ratio, and the ratio, it's a ratio between two sides of a right triangle. Okay, now we know that from the previous lesson, tangent A is opposite over adjacent. Okay, opposite leg. So let's say I'm talking about angle A. So which one is opposite to the angle A? It's BC. So BC is my opposite over the adjacent. So the adjacent is AB. Okay, opposite over adjacent side. Now if I ask you to tell me about the sine A. So the sine A, it's saying opposite over hypotenuse. So related also to the angle A, opposite side is also BC. But the second one, you are talking about hypotenuse. So the hypotenuse is the longest side, and we know that the hypotenuse always is opposite side to related to the right angle. Okay, so AC is my hypotenuse. So this one is my hypotenuse. Now, if you look to the cosine, so the cosine related also to the cosine A. So cosine A is saying adjacent. Which one is the adjacent? This one here is my adjacent over what? Adjacent is AB over hypotenuse. Which one's the hypotenuse? It's here, so which is AC. So if you look here for the sine and cosine, both of them, they have hypotenuse in the denominator, but sine is with the opposite and cosine is with the adjacent. Okay, tan is combined between the opposite over the adjacent. Okay, I hope you understand this. If you have anything, ask me. Now, to let you understand or memorize them, you can memorize this word here. Okay, so if you memorize this word here, or if you write it in front of you when you start doing test, quiz, exam, you will always never forget them. So we call this one SOHCAHTOA. So what is the SOHCAHTOA? Every three letters represent a word. So the first three letters, which is SO, S-O-H here, it's representing the sine ratio. So sine, which is S, start with S, the ratio of the sine is opposite over hypotenuse. So S-O-H. Then we have Ka. So Ka, as you can see here, Ka, which is represented by the cosine, adjacent over hypotenuse. Then the last one here is Tua. Tua is the tangent. So the tangent is opposite over adjacent. So as you can see, all of these three words represent, every three letters represent a ratio. So represents sine opposite over hypotenuse. Okay, Ka represent cosine adjacent over hypotenuse. Tua is represent opposite over adjacent. So just for fun, where did we get the so-called this letter from? So if you look here, let me remove this. So if you remove this one, you can see here some old hippie caught another hippie taking gold apple. Okay, just for fun. Okay, now let's continue. Here, write the trigonometric ratio of each acute angle as a fraction and as a decimal rounded to the nearest thousand. Okay, here we need to write the trigonometric ratio for acute angle. Now, first, always, how many acute angle do we have in right angle triangle? Because we have only one right triangle angle, so the acute angle here is angle D, it's acute, and angle F is acute. Now, let's find them. So let's start find the sine, okay, for angle F. Let's start with angle F. So now, what's the ratio of the sine? So we know that sine is SOH, which is opposite over hypotenuse. So opposite side for F, which one is opposite side for F? It's this one here, which is 15. Okay, which one is the hypotenuse side? So we know that the hypotenuse is opposite to the right angle. So this one here is my hypotenuse. Okay, so hypotenuse is equal 17. So 15 over sine F is 15 over 17. Now, how about the cosine? Okay, let me change the color. So cosine for F. So cosine F, or let's stay with the same color because I'm going to change it to other one. Okay, so cosine F is we know that cosine F C opposite, or sorry, not opposite. So K is AH, so adjacent over hypotenuse. Which one is adjacent related to the angle F? Adjacent is 8. So 8 over hypotenuse. Hypotenuse is 17 over 17. Now the last one, tan F. What is the tan F? So we know that tan K2. So 2, so which is opposite over adjacent. So what's the opposite of F? Is 15. What's the adjacent? Is 8. So 15 over 8. Now let's find them related to the angle D. So sine D. Okay, now let me erase this. Okay, now which side? We know that sine is opposite over hypotenuse. Which one is opposite to the D? Opposite to the D is 8. So 8 over hypotenuse is 17. Now, what is the cosine D? Cosine D is the adjacent over, okay, hypotenuse. So which one is the hypotenuse? It's 17. So 15 over 17. The last one is tan D. So the tan D, always we know that opposite over hypotenuse. Which one? Opposite side to the related to the angle D is 8. So 8 is opposite. Adjacent related to the angle D is 15. So 8 over 15. These are the trigonometric ratio. Okay. Now try to do this one by yourself to find the sine, cosine, tangent related to the angle A. And if you have anything, please ask me. Now let's go here to this type of questions. Okay, let me now differentiate between these two types of questions. The same thing that I explained for the tangent works here for the sine and cosine. Okay, if the question asks you to find a side, okay, you have find, okay, when the question asks you to find side, so you have to use one of the trigonometric sine or cosine or tangent, okay, then you write, okay, then you write the given angle. This angle will be given, this angle will be given, or this angle will be given, equal the two sides. One of them will be given, the other one will be unknown, or the first here will be unknown, this one will be given. Same thing for the cosine. There maybe this one is given and this one is unknown, or this one is unknown, this one is given. Same thing for the tangent, which is we studied in 18.1. Maybe this one is given, this one is unknown, and this one maybe is unknown, this one is given. Okay, so if you look here, you need to differentiate which one you are going to use. Okay, so when the question asks you to find side, you have to use this one. If the question asks you to find, okay, find angle, what I'm going to use here, what do you remember? So I'm going to use the inverse. So I have to use inverse of sine, so something over something, or inverse of cosine, something over something, or tangent inverse something over something. So find angles, I have to use inverse. Find side, I have to use the ratio that we learned. Okay, now let's start with the side here. Let's read the question. Okay, a 12 feet ramp is installed as shown. Okay, the ramp makes an angle of 11 degrees, so the angle here is given, and because the angle is given, so for sure he will ask for the side. So this one here is equal 11. Okay, now find the dimension to the nearest tenth of foot. So he is asking to find what? He's asking to find x, and he asking to find what? He asking to find y. Okay, so now let's start with to find x. So to find x, now what's a trigonometric that you think that I can work with? Should I go using sine, or should I use cosine, or should I use tangent? Okay, if you don't know which one you should or which one you are going to use, so just try all of them. Means example, let's start with the sine. So now let's sine, what's the angle given? We know that sine is 11 equal opposite over what? Over hypotenuse, right? Which one is the hypotenuse here? Hypotenuse is 12. So now let's erase this. So hypotenuse is 12 and opposite is x. So now did this one a rule that I can find x, as I told you here? Okay, so is this one has one missing or one unknown side? Yes. If the question does have unknown, only one unknown side, so you can just now solve it. So how we can solve this one? Similar to what we solved for the tangent. This cross multiply x times 1, so x equal 12 times sine 11. 12 times sine 11. Okay, then you find x, so x is equal 12 times sine 12, 2.28. Okay, or you can just round it to become 2.3. Okay, so now x is equal 2.3. Now let's find y. So after we find x, okay, now let's find y. So find y. So y, what's the relationship between y and the angle? It's adjacent. So let's now use cosine. So cosine 11 is equal. We know that the cosine is the adjacent over hypotenuse, right? And we know the adjacent, which is equal 12. Okay, so now let's replace adjacent with 12. Okay, and y is the unknown side. So do I have one unknown that I can find? Yes. So over 1. So now cross multiply 12 times 1 is equal to 12, equal 11 times y, which is equal y times cosine 11. Now I need to isolate y to find it. So what should I do? So I have to divide by cosine 11. So divide by cosine 11, divide by cosine 11 for both sides. So if you do it in the calculator, these two cancel. So y is equal 12 divide by cosine 11 is equal 12.2. 12.2. So this one here is the y. So y is equal to 12.2. Okay, so as you can see, we have 12.2 and I have 2.3 for x and y, and I hope I understand this. Okay, let's take another example. Okay, here is your turn. Try to solve this one by yourself, but let me help you to solve it because I need you to give you another example to make sure that you understand. Now, suppose a new regulation state the maximum angle a ramp for wheelchair is 8. So the angle here is given 8. So 8 is the angle. At least how long must the new ramp be? Round to the nearest tenth of the foot. Now he gives me this side here, the wall is equal 2.3. Okay, so this one here is 2.3, and he needs me to find z. So now let's just try to use the trigonometric. Okay, so now I will start with tan. So let's start with tan. So tan, the angle given, which is 8, over opposite what? What's the opposite of 8? It's the wall, which is 2.3, over what? Over the adjacent. Okay, so let's say the adjacent is equal AB. Can I find AB? Okay, I can find AB. So now let's find AB. Now to find AB, I need to cross multiply 2.3 equal AB times tan 8, AB times tan 8. So to isolate AB, I have to divide by tan 8 for both sides. Divide by tan 8 for both sides. Then I cancel this 2. So AB is equal 2.3 divided by tan 8 is 16.36. 16.36. Or you can just round it to 16.4. Okay? Now, if you ask me, okay, teacher, why you find AB? The question asks you to find Z. Yes, good questions. Here, I try to use tan to show you that maybe you can try to use any type of a trigonometric, okay, to solve the questions. You need to try all the trigonometric, sine, cosine, tangent, and which one will fit with you, you have to start doing it. Okay? Means the question here doesn't ask for AB, right? The question asks to find Z. And if you look here, I couldn't find Z using tan. So tan is not the one who fitting with the question. So now I have to try another trigonometric ratio. So which trigonometric ratio do you think will help me to find Z? So we know that sine, okay, we know that sine is opposite over what? Hypotenuse. And cosine is equal adjacent over hypotenuse. Okay, now we know that which side here in this triangle is the hypotenuse. The hypotenuse is the Z. Why Z is the hypotenuse? Because it's opposite to the right angle. Okay, so hypotenuse can be found on cosine and hypotenuse can be found on the sine. Okay, but now look to the question. Did the question give me the adjacent side related to the angle A, or did the question give me the opposite side related to the angle A, to the given angle? So if you look here, the question gave me the opposite side. He did not give me the adjacent side. So if he gave me the opposite side and he did not give me the adjacent side, so I can't use the cosine because the adjacent is not given. So sine is given, so I have to use sine to find the opposite. So now let's use the sine ratio. So sine, okay, of the angle 8 equal opposite side, which is 2.3 over Z, which is the adjacent. Now we do the cross multiplying. 2.3 times 1, 2.3 equal Z times 8. So Z times sine 8. So now I have to divide by sine 8 for both sides, sine 8 for the other side. So you can cancel these out. So Z is equal 16.5. Okay, so this one how we can find Z. Okay, maybe some of you will ask me, teacher, okay, teacher, why you use the tan? And, or let's say another question, let's rephrase the question. When you use the tan at the beginning, yeah, teacher, you found the side, right? So you already found AB, which is equal 16.4. So maybe some of you will ask me, teacher, okay, when I found the adjacent, can I use the adjacent, okay, to replace it here and find the hypotenuse? I will say yes, you can. Okay, means if you do it like this, cosine 8 equal the angle that we already found it here, which is 16.4 over the hypotenuse Z, which is we need to find. If you use it like this, I will say it's correct, but it will be long steps, okay, because you need to find first the tan, then you need to find the cosine. But if you use the sine from the beginning, if you use the sine from the first step, so the question can be solved only with one trigonometric ratio, not two. Okay, I hope you understand this. Now let's let's go to the another way of another type of questions, which is finding the angle. And as I told you, finding the angle, it's the easiest part. Find the acute angle measures in each right angle triangle. Okay, so now let's find this. So the question is ask you to find. So how many acute angle? I have angle R and I have angle P. So now let's use angle R. So angle R, okay, is equal. Now here I can't use tan. I need to figure out which trigonometric that I'm going to use. Is it sine, cosine, or tangent? And how can I know which one I'm going to use? You need to use the given side. So side QR is not given. I don't know it. So ignore it. Now look to the angle R. Let's start with R. So the given side is 7 and 13. So what's the relationship between 7 and R? 7 is the opposite, okay, so we know that R7 is my opposite, right, over. Now what's the relationship between R and 13? So this side here is what? Is the hypotenuse. So the 13, which is hypotenuse. Now which ratio will help me to find opposite over hypotenuse? So the ratio opposite over, if you remember, so katoa. So which is opposite over hypotenuse, which is sine. So I can use sine R equal 7 over 13. Okay. So now what can I do now? I have to find shift. Okay, you have to use inverse. R is equal inverse of sine, okay, 7 over 13. So if you do it in the calculator, you will get 32.57, or you can just round it to 33. Okay, now so we found angle R, which is angle R is equal 33. Okay, now let's find angle P. So as I told you, do the same thing. P. Now P is this one here. So now the given side is 7 and 13. So 7, what's the 7 here and what's the 13 here? So 7 is my adjacent related to the angle P, and 13 is my hypotenuse related to the angle P. So which trigonometric that I can use here? I can use cosine. So cosine P is equal 7 over 13. Okay, then to find P I have to use the inverse of cosine. Inverse of cosine is 7 over 13. So do this one in the calculator. Inverse of cosine 7 over 13 is equal 57.4. Okay, I hope you understand this. Now let's do the same thing for the other equation. So as you can see, angle R. So 9, what's the relationship between R and 9? It's opposite. Okay, so this one is opposite, and this side here is the adjacent. So opposite over adjacent, opposite over adjacent. Which trigonometric? Yes, it's tangent. So tangent of R, okay, tangent of R is equal, okay, 9 over 24. So R is equal tangent inverse of tangent, which is 9 over 24. So R is equal 20.5. Okay, the last one now is angle P. So angle P, what's the relationship between this one here? Opposite over, okay, adjacent. Okay, same thing, opposite over adjacent. Also we can use tangent. So tangent of P is equal opposite of 24 over 9. Okay, so the ratio will be P is equal tangent inverse 24 over 9, which is equal 69.4. Okay, I hope you understand this. Now try to solve this question by yourself, and if you finish, please try to solve these questions by yourself, and if you have anything, please ask me. I hope you understand this. Have a good day. See you. Bye bye.